Hey guys, what's up? In today's video, we're building a full stack project with Rust using Actix Web 3. This is what it looks like. So you can add a new post. AI is now going to Mars. The new LLMs are smart enough to build their own rockets. So I'll just put a post like this. You can click on a post, you can edit the posts as well. So if I want to change the spelling and save it, everything looks perfect now. It has pagination as well, and it is the full shebang, like the full CRUD that you get in the front end. Okay, so as you can see on my terminal, I'm running the project, and we're using CORM, SEA-ORM, using Actix Web 3, using Rust and MySQL. Now MySQL is running on Docker here. That's what I recommend. And you'll also notice something weird with my UI today. The reason is that I am using a virtual box today and not on my WSL. So just to show you the project, I'm on my virtual box. The reason is sometimes I do suggest working on VirtualBox rather than WSL because of some packages that can conflict. So I'll talk about that also in a while. Now we are using Actix Web 3 in this project. The reason we're doing that is because it's the most widely used web framework for Rust, and we're using Actix Web 3, not 4, in this project. Now I will, in a few videos, in a few days, I'll launch a video where I'll show you how to upgrade this specific project from Actix Web 3 to Actix Web 4. And the reason we're working with Actix Web 3 today is because if you join a job with Rust, like let's say if you join a new project, join a new job, 99% of the chances are that you'll be working on Actix Web 3. And this is why I want to show you how to learn how to work with Actix Web using Actix Web 3 first, appreciate all the different features. And then I'll show you what's new in Actix Web 4, and I'll upgrade you from 3 to 4, and I'll show you how to upgrade it. So maybe you're in that situation where you've just joined a new project and you've been asked to upgrade from 3 to 4. So this video is perfect for you, right? It's perfect if you're taking your Rust skills to the next level, perfect if you're trying to learn Actix Web, perfect if you're trying to take Actix Web 3 to 4, perfect if you've just joined a new job, a new project. This is the right project for you. Now, as you know, all of these projects are free, and this is an awesome resource, right? Make sure you share it with your friends. You get all of this awesome content for free on this channel. So make sure nobody misses out on this. Now, this video is going to be a part of the 50 Rust project series. I'll place this video somewhere here after the Rust plus Ethereum project because that's where it lies in the difficulty level. Now, all of these projects have been specifically curated by me and they've been arranged in the difficulty level. So if you just start from the first project, go all the way down, you would know Rust really well by building projects. That's how I've done it. We're using Tera. It's a template engine. So if you've used Jinja 2 on Django, if you've used, like I've not used Jinja 2 on Django, by the way, but I know I've used handlebars with JS. So it's very, very similar. I won't even say similar. It's like almost the same. It's like handlebars because, you get the same templating kind of an engine with Tera. It's the same as handlebars if you've used JS handlebars. Exact same thing. So I won't dig down too much into the front end because we're not using like a full-on front end library like React or anything like that. We're doing all the processing on back end. We're doing everything on Rust, just using a templating engine in the front end. That's it. So I'll just leave the front end files with you guys, and we'll go through all the Rust file, which is basically going to render all this in the browser. So I've already built the project for you guys. So I'm Akhil Sharma 90 on GitHub, and the entire project is there. And even though you have the project, the best part is I'll be actually taking you through every single line in this video. So what I was saying was, even if you have the project, just make sure you install it correctly. So you have all of these packages with you, right? So with WSL, I've seen many comments that people put on my YouTube video saying that, hey, this is not working, that's not working on my PC. That's because you probably don't have all of these packages. So I recommend trying out VirtualBox. If it doesn't work on WSL for you, try out VirtualBox. Make sure you have all of these packages before you try to run any Rust programs, especially the ones which have a lot of dependencies like Actix Web 3. Yeah, and with Docker, all of the instructions. So many people are not very comfortable with Docker. I don't know why, but many developers are not very comfortable with Docker. This is why I've mentioned every single detail about how to use Docker for this specific project, at least, like how do you run the container with the port mapped. This is one issue I think somebody was having, and also make sure you write the detached command, because some people are like, if I start Docker, how do I carry on with my other tasks? So I've made sure that I've taken, like, I've put painstakingly, I've put all the details in the README file, so you can't go wrong with this project. Make sure you try to run it properly, and also let's now go through a little bit of visual planning, and then we'll actually start writing the code. So we are having these folders. We have the templates folder where I'm going to place the Tera, all the Tera files that I was talking about. The static folder is going to have just the CSS and the images, and the entity file is going to have my model, which is just my struct, defining how the struct of the post looks like, having an ID, a title, text. Migration will be so you just by the way, just to be clear, if you're using Docker, make sure you use the MySQL image, the MySQL latest image. Don't use the MySQL server image, because that has a different this has different settings, so you'll have to change all the settings yourself manually. Make sure you use MySQL latest, and you just need to create the database name. So if you go to my env file here, you would notice that there is the database name, Actix example. You just need to create the database in your Docker instance that you're running. Just create the database name, and you're good to go, because the tables will actually be created with the migration script. As soon as you run cargo run on this project, the tables will be created. The src has our actual main code, which is going to have our routes, our main function, all of that stuff, and also the complete logic for rendering the templates and the CSS. So it'll have all of that. Okay, awesome. Now let's actually go through how the routes are going to be structured. So let's quickly go over the services that we need. So the services name is list, new, create, edit, and update. These are the services with, and also delete. And the routes that we have look like this. So we have the get method route on the root route to list all of the posts. Then we have the get/new for the new, which is when we actually have to create the pop-up that opens up when we are creating the new post. Actually, it's a whole screen, not just a pop-up. So that's the /new route. Okay, and the way they're set, all of these routes, is basically they render. So we have to think about how to render different screens, because we're handling the front end part also from back end. That's what we're doing. So that's why we have to also think of the screens like a front end engineer, but in the back end side. All right. And we have post route on the root route, post method on the root route, which is for creating a new post, which happens after you see this screen for creating a new post. You enter the form data and then you hit the post route. Then you have the get /ID route, which is to get the specific post, and it says edit. It's a method. The service name is edit, but it's actually just getting that particular value for us to edit. And then update, we'll post the new values in the form using the update, using the post method in the update service. And then we have delete. So delete just uses the post method, and the route looks like this, /delete/id. This is what we're doing. Okay. Then we have our context. So context we're using to store a few things. We are storing the posts, the page, which page is it, and total number of pages, and how many posts are there per page. If you remember, we are doing pagination in the screen, so we're having to maintain the context for how many posts are there in the page, number of pages, all of that stuff, and the posts to be displayed on that particular page. So that's why we have context. And then we have our main function. So we'll have multiple functions. So each of these services will be a separate function, but what we're starting with is the main function. That's what we're starting with. So what we're doing in the main function is we'll be initializing the routes and services first. We'll be connecting with the database. Then we'll run migrations, as you know, just to set up all those tables in the database. So all you need is a database for MySQL to get started with this project. And you want to set up templates, because we're using front-end templates. Then we have the, so we're using Tera, as you know, for the templates. And then we are initializing our app state, creating a new app object with middleware, and then we'll bind the address and start our server. So these are all the things we'll do in the main function. Then here, when we are initializing our routes and services before connecting with the DB, what might happen is we might get the issue for error for DB connection a while after our service starts and waits. So that's not a problem. It's just something that you might want to keep in your mind. But this is the plan. This is what we're doing. So what we'll do now is we'll actually start the project. So what we'll do is we'll create a directory for this project. So I'll call it Rust FullStack YT. I'll cd into this project, open this up in my VS Code. Now you'll realize that I'm no longer in my virtual box. I'm actually in my WSL. The reason is that here I have all the templates, all the plugins, everything set up. So it's very easy for you to follow along. So what we'll do is we'll build the project here with all the nice templates and everything, so that it's very easy for you to view the whole thing. And then we'll shift it to my virtual box where the templates are not set up. Everything looks really ugly, but we'll actually test, because that's where my Docker is running with the MySQL. That's where my Rust is properly installed and set up. Everything is there. So yeah, so we're just building everything here instead. All right, so what we're doing is I have the diagram that I just showed you, the planning, open on another screen. So if you can also take a screenshot of whatever I showed, just open it up on a different screen. And what we'll do is we'll now follow along with that diagram. Okay, so first things first, we'll create the folder structure that we had. So the first folder we had was the entity folder. Then we had our migration folder. Then we had our SRC, our static folder, and templates folder. Okay. We'll also have our .env file. So let's first work on the .env file. .env file will have three things. It'll have host, port, and the database URL. So I'll just copy and paste those values here. So these are, the host is localhost, which is 127.0.0.1, port is 8000. You can change it, and that's my database URL. Now I'll have the post, the model for the post in my entity folder, and I'll have something to do with migration in the migration folder. And then I have my SRC folder. And as you know, for the static and templates, we'll just copy and paste everything here. So we'll be using templates basically, and then for the static file for the CSS, we'll be using a skeleton. We're not going to be building anything on our own because all the rendering is anyways happening in the backend, so we have to work with the backend logic. Okay, so in the SRC folder, I have my main.rs file. In the main.rs file, I'm supposed to be doing a few things. There's obviously the main function here, right? And there is the main function has to be async, obviously, and we're going to write Actix Web here, Actix Web main, to be able to work with Actix Web. So the main function gives us a standard IO result, and we have a diagram of what the main function is supposed to do, right? So at first, I'll just put in all the comments here. So we'll have our environment variables, we'll work with those, we'll get like basically a dot from .env. Then we will get our, we'll set our environment variables for database, etc. Then we'll create our connection string to work with the database. We'll work with migration, etc. So let's just get started. So first things first, what I'll do here is I'll just set the variable for Rust log debug and tracing subscriber fmt init. Then I'll say .env to get the variables, and I'll set the variables for the environment variables. So I'm setting the one for database URL, for host port. So what's happening here is that in the environment file, in the env file, the database URL looks like this, which is capital database URL, and similarly with host and port. But for Rust, we are specifying DB URL, all small, host, port, and so on, because this is what we'll be accessing in our Rust program, and this is what is there in the env file. If we're not able to find these values, we say database URL is not set in .env file, host is not set, blah, blah, blah. Finally, this is the server URL we're going to be using to start our server. And we're formatting the string. This is what the host and port will be. So host is localhost and port is 8000. So it'll be like localhost 8000. That's where the server will be running on. That's where we'll show the server URL. Now, the next thing is the connection with the database. So we'll be connecting with the DB URL, which we have defined here. And before we do all of this, let's get a couple of packages at the top. So let's firstly get the Actix Web package, because that's what we're using. Then we will use the standard env package also, right? These two I think are enough for now. So coming back to our main function, after the main function, I'll also have an init function. So I'll say public function init, and we'll have the web service config. And this function, the init function, is going to help me initialize all of my services. So I'll have configure.service, and my list service. So I'm following the diagram now. So I have the list service, I have the new service, view service, and so on. So I'll just quickly copy and paste this. So I'll change list to new. Then I have my create service, my edit service, update, and delete. Okay, so that's my init function. Then finally, for the so we have our connection URL here, but before this, what we'll do is we'll create a couple of structs here on top. So the first struct that I'll create is my app state struct to handle the app state of the application. It'll have templates, which we are using Tera for. So Tera is like handlebars, which helps us to render templates and pass in dynamic variables and render templates in the front end. And it takes in connection, which is database connection. So con is a field which is of type database connection. Then we, and I'll just derive debug and clone out here. Then we have, so by the way, with Actix Web, we're using all of these things that we get from Actix Web, which is like app, error. Now, app is what we'll be using to initialize our app object, which we'll do in a while in the main function. So be on the lookout for that. And now we just use Tera here for the templates. Then we have another struct called params, which will have page, and it'll have posts. How many posts are there per page? I'll have my debug and deserialize. For serialize and deserialize, we'll be using Serde. So we have done multiple projects before where we have used serialize and deserialize from Serde. Helps us to work with Rust structs, and JSON helps us to convert between both. And then I have my flash data. Now flash data is a struct which has a kind and a message. Flash data is something that we'll be showing to the user. So we'll be saying that, hey, your post has been created or your post has been edited. So all of those small messages, flash messages that we send to the user, which is stored in the temporary memory. So those are flash data, flash message. So it has a message. This is what we'll be showing to the user. Now, once that is clear, we can continue with our main function. So our main function, we have defined the connection string. Now, I'll just move this here. And now we'll work with our migrator. So I'll copy and paste that here. So to the migrator, we're passing the connection variable, which we have with the database. And the database is actually connected with the DB URL variable. And this will run our migration scripts. Then we have our templates. So we're defining templates as a variable, which is of Tera new. And you're saying that all the templates that we'll be using exist in the templates folder. Then we'll initialize a variable called state of type appState. appState is a struct that we have defined earlier. It has two fields, templates and con. So we are saying this is an instance of appState, which has templates and con. And that's what state is. So that's how we're defining it. We'll have listen FD, which we'll be using, a mutable variable, which we'll be using to listen to a particular port in a while. And then we are creating now our server. So to create our server, we are using HTTP server, which is again coming from Actix Web. So to create a server, we need to create a new instance of our object app. App is something that again comes from Actix Web. So we're using Actix Web. Here we'll say .data state.clone. So we're passing data, and then we're passing a couple of other things which are helpful for our middleware. So we have a logger middleware, and we're using Flash, which I shared with you, which is the Flash data which we're showing to the user that hey, the post was created or edited. And then we are passing the init to configure. And for the service, we're using FS files. So we will also get that right now. So we are saying use Actix files as FS. So we're able to use FS as Actix files and get access to files, which we are saying that, hey, use the static folder that we have to render all the static files that you have. And after that, what we'll do is we will say servers equal to match, and we will listen using listen FD on the TCP with the TCP listener, and we are binding the server to the server URL, which will have the host and the port. That's where we'll start listening. Okay. Then we'll print out that hey, the server has started, starting the server at the server URL, which is localhost 8000 or 127.1.1 8000. And we're just running the server, and finally we'll just say okay. So this is our main function. Now we'll to work with all these services which are mentioned here, like list, new, create, edit, update, and delete. We'll actually be working with the entity being the model for the post. So let's go ahead and create that first. So it's in the entity folder. We'll have to create SRC. And the SRC will have two files. One will be the lib.rs and the other will be the post.rs. And this will have its own cargo.toml file. In lib.rs, we will have, we'll just mention that this is a public module, public mod post, and in post.rs we will first import CORM, and then we'll use Serde and Serde, which is for serialize and deserialize. So ORM is something that helps you to talk to the database, right? So in Rust, you will have your own structs of how you will be defining your information, and the database will have its own way of defining the information, and we'll have to serialize and deserialize between these two formats of information. And CORM basically helps us to connect and to also work with different data types from the database. So for the CORM, you're telling CORM that, hey, this is the table name posts, and for struct, you're defining a struct. For Rust, you're defining a struct model, and that will have all the values of how the table posts should be. So it will have all the fields. So we know that there will be ID, integer 32, and there will be title, which is of type string, and there is text of type string as well. Now here we'll derive clone, debug, partial, EQ, serialize, deserialize, etc. And I'll mention that the ID is the primary key, and we'll skip deserializing it because this already exists in the database. The database is doing all this for us as well. And the for text, Rust understands this as text with the small t, whereas the database will have column type. We're defining the column type as text, whereas here we have string. All right. So that's what we have specified to CORM. And we are creating an enum called relation, and we are implementing active model behavior for active model. So active model is something we'll use now in the routes, and it'll be very clear to you if you've never used this before. So just going back to our src folder and our main.rs, what we'll now do is we'll create our first route. So the first route that we'll create is the create route, because that's how we'll interact with our project. We'll create the first post. To create the first post, this is what the route will look like, which is the root route, and will be post, using the post method basically. The function is going to be called async function create, and it gets two things. So the first thing it gets is data, which is coming from app state, data app state, which we've defined in the main function, and we've defined the struct here. So we're getting the app state there, and we're getting data from the form. So now when you are creating a post, right, you're essentially filling data in a form. The form has the title of the post and the text that's supposed to go in the post, and that's the data that we require access to, because we'll take that data and we'll send it to the database using CONN, which is the connection, and that's what's just going to happen in the create function. So this is what it's accepting, but it's returning a flash message. So we'll write that here, that hey, it's returning a flash message, because we're telling the user that hey, the post was created. So we'll start with connection, which is data.connection, and we'll say form is equal to post form.intoInner. Now post form is what we've accepted. We're accepting as args in this function. So we'll get all the data from the form, and we'll be able to access it using this variable called form that we have defined. And whatever is there here from data, we're able to get the connection from there and then assign it to this variable called CONN, which we'll be able to use in our function. Now we'll use active model, right? So active model, which you saw here in your post rs. So that's the one we'll use now, because now we'll tell Rust that this is my post, This is what my post is supposed to look like. So I'm creating my post here. The post will have a title, and I'm going to set that equal to form.title.toOwned. Okay, so from the form I'm getting the value for title and setting that for my value title, field title. Similarly, I'll do that for text, and all the default values will go into default. So now I've created my post, and now all I have to do is I have to just send it to the database. So what I'll do is I will save this to my database, then I'll await for the database's response, and I'm expecting some answer, but if there's an issue, I will return could not insert post. So now this bit is done, like we have now saved it to the database, but then we also need to notify the user that, hey, this post has been saved. So what we'll do is we'll use flash, which is a flash message to inform this to the user. So we'll say flash data, and flash, if you remember, has two fields, kind and message. So here we'll say kind is success, right? So it's either success or failure, and the message is post successfully added. All right. And finally, we'll redirect the user back. So once we have created the post for the user, we'll redirect the user back to the home page where he can see all the other posts that have been created. So we redirect with a response to the home page. So that is our create route. Now we can create our new route, which is when we actually create a post, the page that opens up for the new post to be created, the form that opens up is in the new route. So what we'll do is we'll create get new, and this looks a bit like this. It takes in data, just like we were doing with the create function, taking in data, and returns a result. We'll start with template. So template is equal to data.templates because we have access to data. So we'll say data.templates is equal to template. Makes it easier for us to access the templates. We create context, which is equal to Tera context new, and we create a template body. We're also going to render new.html.tera. So we'll have a page for new.html.tera that's basically going to accept the values from the user for a new post, and we're going to render it to the user. And if there's an issue, then we'll just return template error. But if everything is all right, we'll mark that in our OK, which is that we'll return the HTTP response, which we get from Actix Web. HTTP response, we'll say everything is okay, and we'll render text/HTML for the user with the body, and body basically being the template data. So that's what happens when we hit the /new route. Now the next route is the once we have created something, right? Once we have created a post, we want to get that particular post. So when the user clicks on it, we'll display that particular post. To do that, we'll have the get by ID route. So we'll say get/ID, and as you remember, we're calling it the edit function. Even though we're not editing anything, the editing happens in the update function actually, which also I'll create, which has post ID. So all the update happens there in the update function. But with edit function, we just get the value and we render that value, that particular post in our front end. So the way to start this is pretty straightforward. We start with connection, and we get our template from data.templates, right? Because we have access to data, so we get access to data.con and data.templates. Then we create a post model and we say find by ID. So find by ID, for find by ID we pass the ID, because in this function, if you remember, we're also accepting the ID. So we pass the ID there and we find, we'll try to find it by ID. And we want only one value, so we'll say .1 connection, and then we'll await for the value to come from the database. If there's an issue, we'll say could not find the post, and that's it. So now we'll create our mutex object. So we'll say let mute ctx is equal to Tera context, and we'll insert into the context our post. Finally, so now that we have the post in our context, we just have to render it. So what we'll say is let body is equal to template, just like we did in the new function here. So we'll say let body is equal to template, and then we'll render something here. So we'll render So we'll render headed.html.tera template. And if there's an issue, we'll say template error. And finally, here everything went well, so we'll just say OK response, content type is text HTML, and we are going to be having a body, which is the template. So we're just showing the body in the response. Okay, so that's your get by ID function. Now, if we had to update that and delete that, we'll handle those two situations here, updating and delete. So for delete, the route looks like this, which is delete/id, and the function is going to be called delete. It's going to accept a few values, a couple of values, and also return a couple of values. So for the update function, all right. So we're left with three routes now. So the two we've seen, the update and the delete route, and there will be a list route here. The list route basically is to get the list of all the things that are in our database, all the posts in our database, and the function is going to be called list. It's going to accept some things, going to return a few things, and we'll work on that in a while. So these three routes, before we start working on them, let's do all the other cleanup tasks that we have, which is like creating a cargo.toml file here, and then also filling up this cargo.toml file. Now the thing is, this entity folder is its own, if you see, it's its own module. So this basically helps us keep the code modular, and this part gets compiled on its own, this part gets compiled on its own. That's why they have their own cargo.toml file. And the best part is that in this cargo.toml file, you don't have to get all of the dependencies that are coming in this cargo.toml file. So let me show you what I mean. And this is what makes Rust so awesome to work with. So here, I've just copied and pasted the cargo.toml file from my GitHub project. Make sure you do the same. With toml, the spaces and the formatting is a bit important, so don't mess around with that too much. So this is the name of the project, and you can change it to whatever you want. You can change the name of the author as well. 2021 is what our Actix Web 3 is comfortable with, so make sure you use that. Then you are using Actix HTTP, Flash, files, and you're using Tera, which I've shown you for the templates, .env, listen, FT. Now you're very comfortable with all of these, SERD, right, entity and migration. Entity and migration basically are these two packages that we've created, these two modules that we've created. So we are getting those as well. Then we have CURM dependencies. Now here you'll see that I've commented out Postgres and SQLite because we're using MySQL, but you could be using any of these two databases as well. It'll work perfectly fine. All right. Now the cargo.toml file for entity. And what I will paste here is this, which is again 2021. And the path is src/librs. That's the path that you have to specify. And you have two dependencies. One is SERD and the other is the CORM. So you don't have to get all the other dependencies from the main cargo.toml file. Now you know that migration is also a module on its own. So that means it will have to have its own src folder, and it will have to have its own cargo.toml file as well. So I'll go ahead and create a cargo.toml file, and just need to make sure it's in migration and not in src. So make sure cargo.toml file is always at the level of the yes, I think it is, yeah. So it's at the level of the root of that directory, of that package where you're creating it. So now everything looks fine to me. So make sure you close your src folders and check. So for the migration cargo.toml file, we'll go ahead and copy paste the dependencies that we need here, like for example Tokyo, and that's how you're getting the async std. And then you have your CORM, and then the path is src/librs, and migration is the name of the package that we're importing there out here. Migration and entity. Okay, so that's what the members are here, entity and migration. Okay, so that's how we have set up everything. Now in the src folder in migration, you will have a main.rs file. So you'll say main.rs, and then you'll have your lib.rs file. Okay, so I'll just close off all the other things here so that we're just working with these two, main.rs and lib.rs, and just quickly go ahead and copy paste these scripts for migration that we have found from the internet. So this code was supposed to go in lib.rs, and this code was supposed to go in main.rs. And then there is the file for migration, which does the migration for us. So make sure you go ahead and copy that also, the file that we're basically calling in lib.rs. So now our migration is complete. This is not a critical or important part. We're just doing it to make things easy for us. You could go ahead and just create the table in MySQL on your own. You don't have to run a migration script also. But we're just doing it to, this is like a best practice. Usually when you pick up a project from GitHub, you would always find a migration folder, and that's what I've tried to do basically. That that this is like a best practice in Rust. You'll always see migration folders. Anyhow, now going back to our main.rs, where we are actually writing all the business logic. So going back there, what we'll do now is we will work on the update route. Actually, before that, let me do one thing. Let me also get the static folder. Let me get the CSS from the static folder. Just a second. So the static folder needs to have a CSS folder, and it needs to have a images folder. So images and CSS, and the templates will have a folder called error, and it'll have its own template files. Make sure that you don't post these inside error, because error has its own template for 404. Now what's happening here is you have every single like a different file for every single page. So this is the edit page where you're editing that particular post. Then you have the index page where you're listing all of the posts, right, with the pagination and everything. Then you have your layout page, and then you have the new page where when you create a new post, this is the page that renders, and these are the pages that we are rendering in our routes when we're writing the business logic. And also we have a small page for the 404 error. If it's not found, if that particular route is not found, you're trying to go to that route, you'll get a 404 error. These are our templates, and we just need a little bit of CSS in our project, so that it doesn't look extremely bad. So I just got some CSS. As you can see here, I've mentioned the owner of the CSS as well, I think in the skeleton. So I've mentioned there's a note from Akhil. It says feel free to use this front-end skeleton, but make sure you credit the original author. So do that. So I'm not going to show you how to write this whole CSS because it's a lot of code and it's all front-end stuff, a lot of CSS stuff. Not even front-end, like it's CSS, which is styling stuff. If it was React or Next.js, I would have still, if it was like business logic, I would have covered it. But you can just feel free to copy it. If you're a backend developer, you probably don't care anyways about all this, about the templates and the CSS. There is a dummy image that you need to keep here in images, favicon.png, otherwise it'll just say not found. You can leave it empty also, not a problem. Okay, so now we have all the other things in place, everything else in place. Now we can come back to our main.rs. Okay. So what we'll do now is we'll work with the update function. So in the update function, we are getting two things, data and post form. But for the update, you'll need one more thing. So usually we get data and post form, right, as we've been doing in all the other routes, as you've noticed. But here for update, we're doing just one more thing, which is ID, because when you're updating something, you also have an ID of that particular post. So you're updating by ID. So that's one extra thing we'll need here. And what you return from here again is the Actix flash message. So just go ahead and put that here. And now we'll work inside the function. So for the function, you need two things to start working with. You need the connection to the database, and then you need the form, which is post form, which you're getting here, accepting in the function. And then, just like you did here, you created a post active model. So that's what you'll have to tell. You'll have to define what the model looks like. It'll have its own ID, right? So whatever you're getting, that's the ID you want to keep, because when you're updating something, you don't want to change the ID by mistake. So you say into inner. Whereas for title and text, you're changing. So you're saying to owned. Okay. So you're changing those. Then after the active model, you will save the connection. You will save whatever we have to the database, and then you'll await for the response from the database. And then you'll expect if there's an issue, you'll say could not edit post. And finally, for the user, you'll create a flash message, which has the kind success, and the message is actually post successfully updated. And then finally, you will show, you've shown the message, but now you will respond with redirection so you'll redirect the user back to the home page where you can see all the list of the posts. And this is what actually happens when you use the program. When you update something, you then go back to the home page. Then you have delete, and then after that, we'll finally work with the list, which is listing of all of the posts. So for delete, what we're doing is we again go inside here and we get two things, which is data and ID. So for delete, you need data and ID. You don't need post because you don't have to work with the form data or anything. You just want to delete it. So that's what you just need the ID actually, and data you need for the connection to the database. And then you are going to return the Actix flash message. You start with the connection to the database, and then you create we have a post with the active model, and you find that post by ID. So you say ID, whatever you received in this function, and you find the post by ID, and then you await once you find it using connection to the database. You wait for it, and then you will delete it. So we'll say post.delete. Really straightforward. And finally, once we've deleted the post, we will show a flash message to the user. So I hope you appreciate how I'm piecing the whole code together for you and explaining every single line to you. There is nothing that should be causing any confusion to you by now, because I've explained every single line. If you know basic Rust, and if you've done most of the projects in this series before, there's no rocket science happening here. It's very straightforward. All I wanted to cover was how we work with Actix and Actix Flash and Actix files, all of those things that we've just seen, how to start a server. Those are some new things you've seen, and also how to create these routes with Actix. but all the other logic, like how Rust is written, how all the things that we're doing with Rust, everything I think should be very, very straightforward to you. And also I've explained every single line, but if you have any issues, if you have any questions, doubts, you know that there is there's the comment section, so make sure you comment something. And then also there is the official community for this YouTube channel. Make sure you've joined that, because that's where we discuss all of the awesome stuff about the upcoming videos, the kind of projects we're doing. I share a lot more stuff there, articles that I'm reading, and there's so many awesome people on the community. It's free, obviously, and there's so many awesome people that help you find jobs, help you upskill. You can make a lot of friends. You can hang out there. There's also gaming channels in our server, so make sure you join the official Discord server. What I'll do is I'll leave the link for the Discord server in the description. Sometimes some of the links, they don't work because some of the links could be old, so the one in my profile sometimes does go, but there is a link in my profile for the Discord server, so I'll try to update that as well. But if it doesn't work, there will be one in the description of this video. Okay, so we're done with the delete path. So now we'll work on our list path, which just basically pulls everything from the database and shows to renders the page and shows it. But the only thing is, with the list page, right, we are doing all the logic in the backend and not in the front end. So all the pagination, all of that, and how many posts a page, number of pages, all of that logic also we'll have to handle in the list routes. That's why I was doing it at the end. Usually I do the list routes in the beginning because they're the most simple, because you just fetch from the database and just show it. But here we're also working with the templates, right? So what all do you have in the function as arguments? You have the request object, you have data, and you have option flash data, and then you also have the result. So to start with, you define your templates and your connection to the database. Then you define your parameters, and the parameters will get from the request object, the HTTP request object. The params will have the regular stuff, like the page, like which page do you want to fetch, the number of posts per page. Then you have, you'll create your paginator now, because you now have the connection string and the posts per page. So we'll create our paginator, and we'll define how many numbers of pages will be there with the help of the paginator. So we'll get paginator.numPages, and now we'll actually fetch those posts. So we'll select posts equal to paginator and then fetch pages, and then we'll fetch all the pages. But I'll just format it because somehow it's not getting formatted. And now I'll create my context, and I'll basically insert post pages, post per pages, number pages, everything in the context. So I'll just create a mutable object context with Tera context, and I will insert all of my fields that I need into the context. So I need posts, page, post per page, number of pages. These are all important for me to render my page. Then we'll write flash, option flash inner into, and context insert. We'll insert flash as well. And we will now create our template body. So just like we have been doing for all of the other routes, we'll create our template, which will be index.html.tera, which I've shown you here, which is the list of all of the pages, and we pass the context. Now context, as you know, has flash, has posts, page, post per page, num pages, all of that, all of the things that we'll need on our index page, okay, like posts per page and the post ID, title, text, all of that will be there for each of the posts. So here finally we're just rendering our index.html, and then if there's an error, we'll just show template error, and if everything goes all right, we will just post out the body with text of format text/html. So this is the entire project. So I hope you enjoyed the project, and since I have basically pieced together the entire project step by step, I don't think it will have any errors or issues. And anyways, the code that's on GitHub, it's perfectly debugged. Everything works in it. I showed you the demo before. So make sure you compare everything with it in case you have any issues. Feel free to pick up stuff from it, use it in your projects. If you're building something with Actix Web 3, feel free to pick this up. That's because it's been built quite modularly. You can pick up stuff from here. Now, if you have any issues and doubts, make sure you join the Discord community for this channel, Discord server for this channel, and we discuss a lot of stuff there, as I've mentioned. So I'll leave the link in the description box, or there's a link in my profile as well. So thank you so much for watching this, and we'll soon build the same project with Actix Web 4. Okay, so I'll cover that as well. So make sure you've seen this. So the thing is, the way I've lined up all of the projects in the in my series, the 50 project test series, is that they're building on the knowledge of each other. So in case you're not understanding anything here, this only means that you've not seen the videos before. So make sure you go see them. And the video which will have Actix Web 4, that will basically be covering, will be building on whatever you've learned in this video. All right, so thank you so much for watching, and I'll see you in the next project.